Hello students, welcome back on my lecture Light, Reflection and Refraction. This is my sixth lecture. In this lecture, I am going to cover two topics, that is refraction of light and refraction of light through glass slab. Let us say refraction of light. Light seems to travel along a straight line path in a transparent medium. So, in a transparent medium, light can pass. We all know that. What happens when light enters from one transparent medium to another medium? So this we have not encountered before, right? Whenever light is traveling from one transparent medium to another transparent medium, what happens we'll see. So you might have observed that the bottom of a tank or a pond containing appear to be raised. So when compared to the actual depth, the depth what we see is different. Yes or no? Similarly, when a glass slab is placed on some printed matter, the letter appears raised when we viewed through the glass slab. This is also one of the phenomena due to refraction. Have you seen pencil partly immersed in water in a glass tumbler? It appears to be displaced at the air and water interface. I think you all can perform this in your home only. You take a glass tumbler and keep a pencil inside a glass tumbler where it is half filled. So at the interface between air and the water, the pencil looks like as if it is bent or it is broken. Okay, that is because of refraction of light. A lemon placed in a glass tumbler looks bigger than its actual size. So if you observe the lemon outside, when you have not yet kept inside the water, so it looks smaller. When you put it inside a glass tumbler, okay, when filled with water, so it looks bigger than actual size. Okay, all this phenomenon is due to refraction of light. So the light reflecting from the part of the pencil appear to come from different direction. So that's why we see the light, the pencil is bent. Okay. Okay. When a light travels from rarer medium to denser medium, the ray bends towards the normal. I think you might have got doubt what is rarer medium and denser medium. I will explain you. So here in the diagram, if you observe, here AO is a incident ray, okay, and N dash is a normal, OB is a refracted ray, okay, I is angle of incidence, R is angle of refraction. Here air is mentioned as rarer medium and glass is mentioned as denser medium. So what is rarer medium and denser medium? So whenever we have given two pair of media, whenever we have given a pair of media, so in whichever medium the speed of light is more, that we can call it as rarer medium, and whichever medium the speed of light is less, that we can call it as denser medium. So we have to compare these two mediums and we can tell which is rarer and which is denser. So this is because of density, optical density. Suppose if you think in a traffic road, it is difficult for you to move. So light also same thing. For light also, it is difficult to move in the glass slab because it is more denser, optically denser, and in air it is easily it can move. So speed of light will be more in air, so that is called as rarer medium. Speed of light will be less in glass when compared to air, so that is called as denser medium. So the light becomes slow down and it will bend towards the normal. So here angle of incidence is greater than angle of refraction. It is not the case like reflection. So angle of incidence is not same as angle of reflection. Here it depends on whether light travels from rarer medium to denser medium or denser medium to rarer medium. So here angle of incidence is greater than angle of refraction. Okay. So rarer medium is the medium in which speed of light is greater in a given pair of mediums, that I already told you. Okay. Okay. Now let us see when light ray moves from denser medium to rarer medium. When light travels from denser medium to rarer medium, the light ray bends away from the normal. So if you observe here in this diagram, the previous diagram and this diagram, so the ray bends away from the normal. Okay. Here again n dash is a normal at a point O, I is angle of incidence, R is angle of refraction. Okay. So here I is less than R. You can compare, you can observe in the diagram, R is greater when compared to I. So here in this case, the light is traveling from denser medium to rarer medium. So speed is increasing. Whenever speed increases, it bends away from the normal. Whenever speed decreases, it bends towards the normal. So like this you can keep it in your mind. It is very easy. Okay, denser medium is a medium in which speed of light is less in a given pair of medium. So that I already told you, which is rarer, which is denser, can be decided based on the given pair of medium. So when compared to both the mediums, in whichever medium the speed of light is more, that is rarer. Whichever medium the speed of light is less, that is denser medium. Okay. Next, let us see refraction through a rectangular glass slab. So I can say the combination of both rarer to denser and denser to rarer is refraction through a glass slab. Here you can observe we have taken a glass slab. First in the case EF is a light ray for us. Okay, so EF is a light ray. Light ray is passing through the glass slab as shown in the figure. Okay, ray EF is in air medium and striking the point O on the glass slab. So on the glass slab we have just marked normal, that is n dash. Okay, we have also marked I1 and R1. Okay, I1 and R1 are angle of incidence and angle of refraction. Sorry. So when a ray enters from rarer medium to denser medium, the ray bends towards the normal. So obviously you can say that I1 is greater than R1. I think you can make out. So just now we have studied that. So you can make out. So I1 is greater than R1. So light ray bends towards the normal. Okay. Let the angle of incidence be I1 and angle of refraction be R1. I told you. So n dash be the normal to the point at the point O. Okay. When the light ray reaches point O dash is another point on the another surface between the glass and the air interface. Okay, so here O is a point where it is air and glass interface. O dash is a point from glass to air interface. Okay, so whenever light ray travels from glass to air, so what happens? Glass slab is a denser medium when compared to air. So in air it is a rarer medium. So ray bends away from the normal. When the light ray reaches O dash, it's moving from denser medium to rarer medium. So the light ray bends away from the normal and emerges along GH. So I have just marked the ray as GH here. Okay, let the angle of incidence be I2 and angle of refraction be R2. So here if you observe I2 and R2, so here R2 is greater than I2 or I2 is less than R2, we can say. The line OP is the actual path of the light if glass slab was not present. Suppose if you take off the glass slab from that place, the ray must have gone along EFOP. You can observe in the diagram EFOP, that is a straight line. So it is shown as a dotted line in the diagram. So dotted line is the actual path of the light if there is no glass slab. If there is no glass slab, the light ray would have gone along OP. But due to glass slab, what is happening? It is refracting two times. First time it is bending towards the normal. Okay. Second time it is bending away from the normal. Up to what extent it bends in the first refraction, to the same extent it will bend away in the second extent. So what happens? The emergent ray will be parallel to the actual path of the light. It is parallel to the actual path of the light. So M dash is the normal at point O dash, M dash. Okay, there it is N dash, here it is M dash. Okay. The emergent ray along GH is parallel to line OP. So you can observe OP. Okay, OP you can observe in the diagram, the dotted line. For that dotted line, the emergent ray, that is GH line, is parallel. So the perpendicular distance ML, you can observe in the diagram properly. ML is a perpendicular distance between the emergent ray and the actual path of the light. So that distance we will call it as lateral shift. It just looks like as if the ray is shifted laterally. So that's why we will name it as lateral shift in this case. Okay. Hope you have understood all these concepts. Okay, let me explain once again. Here EF is a light ray which I am incident on point O, which is a rarer medium to denser medium, air to glass. So it bends towards the normal. And in the next case, again when it goes out of the glass, from glass to air, it bends away from the normal. So these are the two cases, two refractions which is happening. After two refractions, the emergent ray will be parallel to the actual path of the light if glass slab was not present. So this parallel shift, we'll call it as lateral shift. Okay, I think hope you all understood this today's concept. That's it for today. Thank you. In next lecture, we'll see how image is formed in lenses, okay, and refractive index and loss of refraction, all such things. Thank you guys.